Oh, there we go. All right, so if we look at number 1, well, actually, before we write this down, at the top of the page, we're going to go ahead and write that when we find common denominators, the very first step is to factor the denominators. So we're going to factor the denominators completely. And then our second step is we're going to take all of those factors, and that's what's going to make up our common denominator, okay? So we're going to say use those factors to make the common denominator. All right, so for the first problem, when we factor 7, 7 is a prime number, so we're just going to leave it alone. We're going to say that the factor of 7 is just 7. I'm going to ignore the rest of it because that's about as simple as it can be. But what do you get when you factor 21? 7 and 3. All right, so our common denominator needs to have all of those factors. I can see that the factor 7 is already in common. There's one in the left fraction, there's one in the right fraction, so 7 is definitely part of the common denominator. It needs to be there because it's in both. And the right fraction has a 3, so I know my common denominator needs to have the 3 as well. So I'm going to say, yep, keep the 3. So overall, what's my common denominator? 21. All right. What do you get if you try to factor 2? 1 and 2, we're just going to call it 2. We don't really need 1s in here because they won't do anything. So the 2. How do you factor 9? 3 and 3. So factors are the very smallest numbers. They're always prime. The common denominator is not like a least, it's not like a greatest common factor. You have to have all the factors included in it. So it would be 21. All the factors have to be inside of it. Because this one cannot be written, well, it could be written in terms of sevenths, but they can't always. So you write down all the factors you have, and then you include all of them. We're going to keep doing examples. If you don't get it on the first one, it's okay. Because we're going to do like 15 more. All right. Yes, ma'am. So it depends on the problem. You're going to see it more on the second one. Okay. So on this one, our common denominator needs what? Yeah, it needs a 2 for sure, right? Because we can see a 2 in this one. And this common denominator actually needs 2 3s. Not just one, it needs 2 of them. Does anyone see the difference between problem number 1 and problem number 2? Because problem number 1 had 2 7s, but we only needed 1 of them. Problem number 2 has 2 3s, and we need 2 of them. Yeah, Erica, what were you saying? Yeah, and that's what we're trying to answer. So why did we only need 1 7 over here? Why do we need 2 3s over here? Yeah. Yeah. So on this one, each fraction only had 1 7. So at most, you only needed 1 of them. In this problem, you've got a fraction that's got 2 3s. That's why you need 2 of them. So it's whichever fraction has the most of that number, that's what you take. Okay? So this had 2 3s, so we had to have 2 3s. Yeah.
So the 2 had a 3 along with it, you would only have to have 1 3?
No, if the 2 had a 3 along with it, you would say which fraction had more 3s, the left fraction or the right fraction. Whichever one has more wins. So this one, because that was 2, if the left fraction had happened to have 1 3 and this one has 2, you would have used 2 because that one had more. Okay. In the first fraction, each of the numbers only had at most 1 of the numbers. And that's why we only needed 1 of each number. Over here, we've got a fraction that's got 2 of them. Okay. Go ahead and factor number 3. So factor your denominators to see what they've got. And on 12, you want to break it all the way down. So at the very end, I should see 3 numbers that go with 12. 3. So you got to break it. You got to break it all the way down. It's kind of, when you do this, it's kind of like doing factor trees. If you guys remember factor trees from back in the day, it's very similar to that idea. Say it again. Yeah, so then you have 3 numbers, 2, 2, 3. All right, so what are some numbers that multiply to 12? 6 and 2. And can one of those numbers be broken down again? Yes. Which one can't? The 6. So 6 is the same as 3 times 2, and I'm going to keep that times 2 from there. Okay. So 3 times 2 times 2, those are the factors for 12. All right. How do you factor 15? 3 and 5. Okay. So we've got 3 times 2 times 2, and we've got 3 times 5. So what number do we need to have in our common denominator?
2.
How many 2's do we have to have? We need to have 2 of them. All right? Because we got one fraction having 2, so we need to have both of them in there. How many 3's do we need to have? 1, because at the very most, each fraction only had one of them. So we need 1 3, and then what else do we need? We need 1 5. Okay, so if we multiply those together, 2 times 2 times 3 times 5 is 60, so our common denominator is 60 here. Huh? So number 2, we could have gone to the end and said our common denominator is 18. I just forgot to do it. Yeah. I only used 1 because each one only had 1. I had to use 2 2's because one of the fractions did have 2 of them at the same time. So each number, you only use it as many times as it was used the most in one fraction. Okay. We are going to go ahead and flip the paper over, and we're going to look at the high school version of these. Okay? All right. So how do you factor 5? We're just going to say 5. 5 times 1 technically, but the 1 would not change our common denominator at all. And then how do you factor 2y squared?
2y.
Yeah, that's 2y, right? So what does our common denominator need to have? It needs a 5, it needs a 2, and it needs a y. So what is the common denominator? Yeah, it's not too bad. All right, go ahead and try number 2. See if you can do number 2. No, you got it. You can do it.
Would you start with 2 and 2?
I would start with 2 and 2. So we got 2, 2. What else do you have for that first fraction? X, Y, Y. All right, and then your second fraction, when you factor it, what is it? Just a 2. All right. So how many 2's does our common denominator need? Needs 2 of them. Why does it not need 3? At the very most, it was used twice on a side. Okay. What else do we need? X and a y. So what is your common denominator? 4xy squared. It is the same thing, you're right. It's the same thing as the left fraction. So that means the left fraction already has the common denominator. All right, now I do want you to write it out like this. I want you to write out these pieces and then write out this as your common denominator, because we're not doing all of this today. At the end of today, we are not going to be able to add and subtract rational expressions. All we're going to be able to do by the end of the day today is find common denominators. That's it. On Monday, we're going to take it a step further, because tomorrow you have a sub, right? You have a sub tomorrow. Tomorrow we're taking a quiz. So not on this, no. So on Monday, we'll take it a step further, and to take it a step further on Monday, it's going to be helpful if you have all this stuff written out. Okay, so please, on every problem today, even when it gets easier, even when you can start to do it on your head, write it out, because the next step is kind of difficult as well, and this is going to make our lives easier tomorrow, or on Monday. All right? Okay. We're going to jump down to problem number 7, because problem number 7 looks a little bit different. Wait, don't start number 7 yet, because you're going to do it wrong. What makes number 7 different? It's got a plus in it, right? So this plus is a group. Let's put parentheses around that. That's a group. How do we factor groups that look like that? We have 4 methods of factoring these. We got GCF. We got difference of squares. We got diamond. We got slide divide. Is it difference of squares? It's got a plus, not a minus. It's a GCF problem. Okay, so let's factor this. We're going to use a GCF. So what's the GCF of this problem? 2x. And once you take the GCF out, what's left over? 2x plus 1. Good. So that fraction on the left, it has 3 factors that go towards the common denominator. One of the factors is a 2. One of the factors is an x. The third factor is the 2x plus 1. That's 3 factors that fraction contributes to the common denominator. Yeah.
So you got one term.
Yeah, so this with parentheses, that is one big factor. That is one big thing altogether. And then the 2x, how do I factor that? 2 and x. Okay, so if we look at our common denominator for this one, what does it need?
2.
It needs a 2. So they each had 1, 2. They each had 1x.
2x plus 1.
And it needs a 2x plus 1. Yeah. So when we do our common denominators, this was a good question. Are you listening? Alex, are you listening? All right. So when we write our common denominators, we can go ahead and just multiply the stuff that's in front of the parentheses and say overall, we are concluding that our common denominator is 2x times 2x plus 1. We do not need to distribute this. The only reason I'm saying not to is because in a few days we will learn that it makes the problem easier if we don't. Okay? For today, there's not a good explanation why. In the future, you will understand why we do not multiply them out. Okay? So for now, if we have something like this, we do not distribute. Okay. So this is where we're going towards. This is why I taught you how to find common denominators the way that I did, because it makes it make more sense once we get to problems that look like this. All right? Let's go back up. We're going to skip, for today, we're going to skip number 3, and we're going to skip number 8 today. Don't X out the whole thing. We're going to do them on Monday. But we're going to skip number 3 today, we're going to skip number 8 today, and we're going to skip number 9 today. Okay? So all the check me problems we're going to skip for today. Okay? All right, let's look at number 4. Go ahead and factor each of your denominators in number 4. Anyone want to share what pieces you got? What little factors? Yeah.
So for 6y for third,
Uh-huh.
I got 3 times 2, well, I'm about to do that.
Okay, so what did you do for your common denominator?
I put 3 times 2 and then 2 times x for the third. And
Okay, so x, because we had 3 of them.
And then y.
Okay, so we're writing all those out.
6x cubed
So you also 2 twos up there. 2 are the same.
If it happened to be on the same fraction that you have 2 of them. Yeah. Yep, we only needed 1, 2 because each fraction only had 1, 2. They are long. That's why you gotta come to class, right? All right, go ahead and work on 5 and 6. So 5 and 6, I think we're ready for those. 5 and 6, those are the ones we're working on right now. 5 and 6. So what did you guys do on 5? So okay, so you did 2 2s and a 3 and a y and an x, and then what did you conclude? 12. Yeah. And x, y, and yx are the same. We just typically do alphabetical order. So if you wrote yx, you're not wrong. We just typically do alphabetical order. All right, and then on 6, we've got 2 times 3. Okay, so our common denominator needs what? It needs a 3. It needs 2 2s. And so overall, what's our common denominator? Yeah. Well, we looked at which side had more of them. And the right side had 2 of them, so I ignored the left side. I didn't care at all, yeah. So whichever one has more wins. All right, let's jump down to number 11. We're going to jump down to number 11. All right. I've got this one with a plus in it. What do I do as soon as I see that plus? I put parentheses around it. And since it's got a plus, my only option for factoring is difference of squares, GCF, diamond, slide, divide. Those are the only possible ways I can factor this. So, can I factor k plus x further? I cannot. Okay? So that is the factor. The factor right here, we're going to say, yep, that's just that one factor. It's just k plus x, one thing. And then... and then what's the factors for 6k squared? All right. So what does our common denominator need? Not 3, just 2. Okay, k and a k. What else does it need? A 3. What else does it need? A 2, and I heard somebody else say a k plus 6. Good. So what would we say our common denominator is overall?
6k squared k plus 4.
We're not going to multiply them out, and the only reason I have for that is that in a few days it will make our lives easier. For today, I don't have any reason to justify that, but in a few days I'll be able to explain it, and it will be because it makes our lives easier. All right, go ahead and try number 12. Number 12 is an interesting one. On number 12, you're going to feel like, is it that easy? Because it seems like it should be more difficult. That's how you should feel when you do number 12. You might have already found it, yeah. So what's one of your factors on number 12 that you came up with for your common denominator? M minus 2. Yep, that's a factor by itself.
3m plus 5.
And 3m plus 5 is the other factor. That's it. We got two groups. The two groups were different, so we needed both of them. Okay. Go down to number 15 and scratch it out. All right. Now, your homework, that one just is it's a GCF and a diamond problem mixed into one. And it's honestly, the common denominator is just if you multiply the two denominators together. It just looks worse than it needs to look on your first assignment practicing this. So, all right. So your homework tonight is to just finish this side of the worksheet of finding your common denominators. Okay? Huh? You don't do the check me's. You leave those for Monday.